Welcome to our Moodlebox presentation series. In our last video, I have introduced Moodlebox, a Moodle server running on Raspberry Pi that can be used as an alternative solution to delivering instruction in times of emergencies. In this episode, I will be going over the details of extending the coverage of the wireless local area network of the Moodlebox microserver in order to reach more students at longer distances than what Raspberry Pi can offer by itself. I will also show you how to pair Moodlebox with a content repository called the Tambayayong e-library box that also runs on Raspberry Pi.
The first configuration, we will have two Raspberry Pi. So what we have here is one on top of each other. One would be the Moodlebox microserver, and the other would be the Tambayayong e-lib box. So to expand the number of concurrent users, the first configuration will require an Ethernet cable, preferably a short one. So all you have to do is to connect the two Raspberry Pis together, and this can be an ordinary Ethernet cable, doesn't have to be crossover. The RPi will reconfigure itself and will be able to talk to one another after we have changed the configurations. So that's the first network configuration for expanding the number of concurrent users to about 30, 10 to 15 per each Raspberry Pi.
This presentation is intended for educators with technical knowledge of local area networking using Linux and educators looking for a small-scale solution to online learning under the following conditions: emergency situation, in remote locations, and those with access and cost problems with regards to the internet. This presentation is not for students. This presentation is for educators and schools. So our digital solution is meant to be for remote learning and for distance education. The problem that we are trying to address is when students and teachers have no access to the internet. So our solution is to extend the wireless local area network coverage of the learning management system. In this case, we are making Moodlebox as a router and using an external access point. We are also using in another video a dedicated router to connect to Moodlebox and with an external access point instead of using the Moodlebox as the router. So for this video, it would be without a dedicated router but using Moodlebox as a router. So the first solution that we'll present here is less costly than the second but would require more configuration settings. We will also discuss in this series the problem of having no electricity, which is a common complaint among those teachers who are implementing remote teaching and distance or online learning. We will discuss this in a separate video by using a low power device, of course a Raspberry Pi, and then using batteries and suggesting the use of solar panels to charge those batteries. But this will be in another video. So what is the rationale of this series? So due to the pandemic and numerous calamities in the country, we need a platform for remote learning that does not require connection to the internet or connection to the electric grid, but at the same time provides most, if not all, of the advantages of e-learning and maintains physical distance between teachers and students. Now we want an educational technology that can empower educators who provide remote learning in times of emergency. This means that the hardware technology should be available to them. Either they already possess those hardware, or they can repurpose them for emergency needs, or they can purchase affordable off-the-shelf hardware. And also, they can leverage their prior learning of online educational technology or extend what they are already doing now, like the mobile learning hub. In other words, our solution would be portable enough so that the mobile learning hub can make use of them. You can put them in a jeepney, you can put them in a bangka, you can put them in a pajak, or you can just carry them around and bring them to the community where the students reside. The solution cannot be technological alone. It will always require a fair amount of human organization to leverage the synthesis of existing educational technology described in this presentation. So what is Moodlebox? Moodlebox is a custom Moodle software able to run in a low-power device like Raspberry Pi. So Moodle is just an LMS, a learning management system without content. It is the virtual equivalent of an empty classroom, but with tools for teaching and learning. We will not be discussing how to install Moodlebox on a Raspberry Pi in this video. You can see the following videos for an introduction on Moodlebox. These are videos that I have presented before. In addition to Moodlebox, because Moodlebox is an empty classroom or can be considered as an empty classroom, we will need content. So we will pair Moodlebox with a content repository. So in this case, we will use the Tambayayong e-library box, which is a content repository that is seeded with curated content from UP Silab. This also runs on Raspberry Pi. Now, what are the advantages of Raspberry Pi and similar devices? As we have said, we need something that is low-powered and it is relatively cheap so that if something happens with the device, we can easily replace it, and because it is portable. But there are some problems with Raspberry Pi. Particularly, the number of simultaneous Wi-Fi access is limited, probably around 10. And the range of the Wi-Fi access is limited as well, around 10 meters in my test with clear line of sight, meaning there are no obstructions. So the estimated concurrent users and range of the Wi-Fi of Raspberry Pi is as follows. With one Raspberry Pi, 10 to 15 students can connect. And the distance from the microserver should be around 10 meters. With two Raspberry Pi connected by Ethernet, you can connect 20 to 30 students. So 10 to 15 students connecting to each RPi that serves as an access point. So you would have two access points. But the distance would still be 10 meters from either one of the microservers. The third solution that we are exploring would be two Raspberry Pis with an external access point. The access point are advertised to allow concurrent users to connect to around 50 students, but I have not tested that. And in my range test, the effective distance would be about 36 meters, and this is an urban environment with obstruction. So what is the estimated cost? These are 2020 online retail prices, and it does not include shipping. For a Raspberry Pi 8GB, this is RPi 4, the cost was 4,499. You also need a power supply. This is an adapter. Cost is 569 pesos. And then the Raspberry Pi case that I use costs around 399 pesos. I also needed a heatsink for Raspberry Pi 4 at 120 pesos. And a micro SD card, which is 64GB for, this is SanDisk, right? So this is 374 pesos. And then for networking, we may need a desktop switch. I bought mine for 600 pesos. And then you need an external access point device. This one I bought for 1,568 pesos. and a Wi-Fi router costing 2,000 pesos. And then for power, this will be discussed in another video, but I'll mention the cost here. For an RPi lithium battery power pack, this is for RPi 3, it's 456 pesos. The current version that is suitable for Raspberry Pi 4 would be around 1,000 pesos. And then alternatively, you can use a solar battery kit. So this is battery and solar panel. This one cost me around 10,699 pesos. And then you will also need high quality power USB cable, Type C for RPi 4 and micro USB for RPi 3. What I found that works with Anchor, and this costs around 790 pesos. Of course, the price would have changed by now. So our first solution is connecting two Raspberry Pi together. One is Moodlebox and one is the Tambayayong Eli box. So this is the setup. You merely connect the Ethernet ports via Ethernet cable. What are the changes that we need to do to the Moodlebox? So temporarily, I would attach a keyboard and a monitor to the Raspberry Pi because it's easier to modify it this way than through SSH. For a fresh install of Moodlebox, the default admin credentials for the Moodle from the command line are Moodlebox, and the password is Moodlebox $4. Naturally, you will change this in order to secure your Moodlebox later. Now, for SSH access, you can see this link. So if you want to do SSH instead of directly connecting a keyboard and monitor to your Raspberry Pi to work on it, then you may do so. So what are the changes to the Moodlebox configuration files? So we need to make changes to the Ethernet interface to grant a static IP address to the Moodlebox server, and make the Moodlebox server a domain name server for the local network. Okay, so the files we're going to modify would be etc/host, etc/dhcpcd.conf, and etc/dnsmaskq.conf. So the changes we need to do with etc/host file of Moodlebox, we add the Tambayayong e-library box hostname with a given IP address. I assigned the library address, the IP address 192.168.1.2, and the domain name or host name library to the Tambayayong e-live box. We do this in the Moodlebox server, take note, so that the Moodlebox would be able to communicate with the content repository Tambayayong. And then here's an example of my etc. etc/host file. This is the line that I have added. Okay. And then we make changes to etc/dhcpcd.conf. I added a static IP configuration for the Moodlebox and two deny interfaces line. Okay, here is an example of the static IP configuration. Okay, so this one, okay, and then deny interfaces. We can edit the terminal. I usually use nano, so I just issue sudo nano etc/dhcpcd.conf, and then after modifying it, I saved it. And then we changed the etc/dnsmaskq.conf. I added entries for the Moodlebox H0 LAN or local area network. So the first thing I did was to bind the MAC address of the Tambayayong e-library box, which is in my case this BA227EB AA88E1, to the IP address 192.168.1.2. And then I make the Moodlebox DNS server give the name library to the Tambayayong e-live box. The full domain name of the Tambayayong box would then be library.home. Just like the domain name of the Moodlebox microserver is moodlebox.home. So this is the line that I've added to dnsmasq.conf. Okay. And an example of the configuration file. Here are the added lines. Okay, so this is the network configuration of the two RPi serving as two access points. So if a smart phone by a student wants to connect to the wireless local area network, he or she can either connect to Moodlebox and he could still access Tambayayong through Moodlebox, or he or she could connect to Tambayayong and he could still access Moodlebox through Tambayayong. That's why we're saying that we have increased it, double the number of students who can access the server at the same time. So let's now proceed to changing the configuration of the Tambayayong e-library box. Again, I'd use a keyboard or monitor, and then for a fresh install of the Tambayayong e-lib box, the default admin credentials, well, I remember when I downloaded this, it could have changed already. Just check your the Tambayayong documentation. But these are probably the default Raspbian or Raspberry Pi OS credentials. So the username would be Pi and the password would be Raspberry. Again, you will change this so as to secure your Tambayayong e-library box. So the first change that we need to do with Tambayayong box will serve is so that it will serve as an extra access point for Moodlebox while keeping its own subnetwork for its WLAN for direct access to the e-library box. So the following files will be modified: etc host and etc dnsmasq. We will also need to set up IP tables to route traffic from Tambayayong box WLAN to Moodlebox via the LAN wired subnetwork. So the changes to the etc host file of the Tambayayong e-library box. So what I did was I removed the .ph domain in the original file, and I'm now using the .home domain of Moodlebox. I added the following line so that the Tambayayong can resolve the Moodlebox domain name. Okay. Here's an example of the etc/host file of Tambayayong e-lib box. Okay. And then I made changes to the etc. etc//dnsmasq file of Tambayayong e-lib box. I added a server line in the file, this line. Okay. These are just comments. So its server equals 192.168.1.1. 192.168.1.1 is the IP address of the Moodlebox DNS server. So when when a student queries for, let's say, Moodlebox.home, what the Tambayayong box would do if they are connected to Tambayayong box is that it will ask the Moodlebox for the IP address. How do you resolve Moodlebox.home? And Moodlebox would give the IP address 192.168.1.1, or would resolve it and then tell Tambayayong that yes, that's me, that's Moodlebox. Then it will provide the Moodlebox websites via the Tambayayong e-lib box to the student's device. So here's an example of the dnsmasq file of the Tambayayong e-lib box. I only added one line which identifies Moodlebox as the domain name server of the local area network. Okay, now we have to install IP tables persistent. So issue sudo apt install IP tables -persistent. We need this tool for routing. Okay, now let's set up the, we need to create a file in etc forward slash sysctl-d.d slash routed-ap.conf file. So using nano, I added the following line: net.ipv4.ip underscore forward equals 1. And then I added the firewall rule. Okay, so the firewall rule is this in the tambayayong e-library box. This is sudo iptables-t nat-a post routing-o h0-j masquerade. Then we save the current firewall rules to IPv4 by issuing the command sudo netfilter-persistent save. This will automatically create the folder etc/iptables and the file etc/iptables/rules.v4. Then reboot the tambayayong e-library box. Issue the command in a terminal sudo reboot. Okay, so congratulations, now a teacher can embed URL links from the tambayayong e-library resources in Moodlebox. When the student clicks on the link, they will be redirected to the tambayayong e-library box, or will just play it as embedded file. Now you're saying, what's the big deal with this? You can do this very easily in your computer connected to the internet. That is true because servers that you do not see behind the browser are doing all of these things that we have set up, right? Connecting different servers together. But since we're not connected to the internet, we have to do this by ourselves in our wireless local area network, just so that we can embed a video served by the tambayayong e-library box inside our Moodlebox learning management system. Okay, that's one solution. We only had, remember, we just connected two Raspberry Pis together.
Okay, in this configuration, we will be expanding or extending the range of the Wi-Fi to around 36 meters or farther by using an external AP. So again, we have our two Raspberry Pis. This one is on a rack. So we have one, the Moodle server or Moodlebox server, and then we have the Tambayayong eLive. These two here at the bottom are the lithium batteries, but we will power that up later when we discuss how to resolve having no electricity in another part of this presentation. So we will be needing, well, this is optional, but I prefer to use a desktop switch so that later on I can expand the number of RPIs that I can attach. Okay, and then to connect the desktop switch, we'll be using two Ethernet cables. So all we have to do is attach our RPI microservers to the desktop switch. Okay. Next is we will add an external, okay, so we will add our external access point. So to connect this, since this is running OpenWRT, we will use the, okay, so this kind of external access point requires what is known as a power over Ethernet adapter. So we have here the uh, PoE, and this is the electrical plug. So we have two connectors. One says PoE, power over Ethernet, and then LAN. So what we do here is that we connect the PoE. So we will need another two Ethernet cables. So we will connect the PoE so that we can supply power and at the same time transmit data. So from PoE, in the PoE adapter, we connect this to the LAN Ethernet port, at least for OpenWRT. And then we connect the LAN port of the PoE adapter to our desktop switch. Okay, so there you have the complete configuration for extending the wireless network of your Raspberry Pi using an external access point device.
Now we are going to extend the range of the the coverage of the wireless local area network with an external access point. So here's our setup. We have the two Raspberry Pis. One is the Tambayayong and the other is Moodlebox. Then we attach them to a desktop switch and then connect an access point to the switch via its power over Ethernet adapter using Ethernet cables. So this is an example of an access point device that I'm using, the Comfast CFEW71, somewhat popular among piso Wi-Fi providers. So note that the Ethernet cable would be connected to the LAN and not the WAN, because what I did was I replaced the software of this device with OpenWRT. And here are some links if you want to do that. Okay. Supposedly, if you replace it with OpenWRT, it becomes more stable. But we'll see. Okay, now in our AP device, access point device, we access the administration. This is Lucy, the administration software of OpenWRT. Here we go to Network Wireless menu, and then we edit the wireless interface, the one with the SSID. Okay. So we have to make sure that the mode is access point in this interface configuration, and we change the ESSID to the name of the Wi-Fi network SSID you want to broadcast. Mine, I named it Moodlebox 3. Okay, then click save. Then we set up the access point Wi-Fi. Click on wireless security tab, and then in encryption set, I set mine to WPA2-PSK, and the cipher is auto. Then I type in the key, which is the password to the Wi-Fi network. So whenever you connect to a network, you type in the password. This will be it. Then click save button. Okay. Then afterwards, when you return to the wireless overview, you need to click save and apply button to apply all the changes in the settings of the AP or access point Wi-Fi. The next thing that we have to change in our access point device is to set a static IP address for the AP LAN. Okay? So we do this after setting up the Moodlebox as the LAN DHCP server. We now go to network and then interfaces. Okay. Then click on the edit button of the LAN interface. Now, we then click on the general settings tab and make sure that the protocol is static address. We change the IPv4 address if you want. Make sure that the first three numbers are the same as the IP of your DHCP server. In this case, the DHCP server is Moodlebox with an IP of 192.168.1.1. So the first three ends with 0.1, right? So that it is in the same domain and you can access the Lucy configuration interface of this access point device later on. Okay, so here I changed the IPv4 address to 192.168.1.52. And then again, under interfaces, we click save and apply button. Okay. Next, okay, we disable the AP DHCP server because you can only have one DHCP server in a network. So in this case, the LAN network, we already turned our Moodlebox into the LAN DHCP server. So the AP DHCP server would then be disabled. So go to network interfaces again, then click the LAN interface edit button again, then under the DHCP server tab and general interface setup tab, we enable or check ignore interface setting. This will disable the DHCP server for this interface, which is the LAN. Okay, the local area network, which is the cabled Ethernet network that connects to the servers. Okay. Then click save button. Then again, in the interfaces page, click save and apply. Don't forget that. Okay, so once we have the expanded or increased the range as well as the number of concurrent users of students, we can now take our entire assembly or network device setup and put it, let's say for instance, in a jeepney, and then we can add another AP device in another jeepney. Let's say this is where your server is. We can actually add another AP here and bridge that, and then another AP here, access point device, and then we just bridge that to this, bridge that to this, and then what would happen is we will increase even further the range of our device. Of course, there will be a limit to this, otherwise it will be too laggy. This will allow us to circumvent obstruction like these trees and buildings. And in addition, because our microserver and AP devices are mobile, we could actually schedule the time for a student to connect to the Moodlebox server. And then by using let's say the Moodle mobile client, they will be able to download while they are connected during a specific schedule. While they're connected, they will be able to download the entire course content. And at the same time, after they have all the students within that area have downloaded it, the mobile hub that is carrying the server and the AP can actually move to a different location. Thus, you can extend it even further, and then you can serve more students even beyond the 40 or 90 students maximum of this AP, of these access points and the microserver. So you just need to schedule. Let's say, for instance, from 8 to 8, 9, 10, 8, or in the morning, for instance, you have a morning session, you bring your mobile hub to Barangay A. Okay. So in the morning, the students have the time to download, and at the same time, while they're connected, after they have completed the downloaded content and then done the activities offline while the hub is away, when the hub returns the next day in a morning session, for instance, then they will, when they connect, the Moodle mobile software or app will automatically sync and upload their answers to quizzes or their submissions of assignments and their posts in discussion forums. So this would require a little bit of organization of our human resources. You can also put the Moodlebox and Tambayayong Live or any content repository pair wireless local area network system on bangkas, when there is flooding, or in remote islands, or in places where there are obstructions due to mountains. You can circumvent the problem of the mountain range blocking the network signal by placing strategically your mobile hubs. So strategic location of microservers is useful in order to extend further the coverage of your Moodle box and content repository. To do this, it would be good to have the geolocation data of your students and analyze this using a geographic information system, for instance, the open software QGIS, so that you can do an advanced range testing of the clusters of students, and also possibly for evacuation centers in case students move away from their residence. And this will require some self-organizing skills of stakeholders in an emergency situation. But you also have to consider also the issue of security. We do not want just anybody to put up these servers and have the students register, because you have to worry about privacy and the possibility that someone would just be collecting data from the student. It would be better for a school to manage this and then pre-register the students in the Moodle boxes and disallow any registration, so that only their students will be able to connect to their devices, and the students know that the devices are actually from their school. Of course, hopefully those who have listened to this presentation would also reply with other ways in order to secure the Moodle boxes if deployed in this way. Let's say, for instance, using the HTTPS, which I did not test for this Moodle box, and so on. So we hope that the viewers of this presentation who have knowledge in local area networking will be able to provide us with additional security measures for the privacy of the students. What I presented in this episode is the extension of the wireless local area network of the Moodlebox and Tambayayong e-library box microservers in order to reach more students at longer distances. Hopefully, you will find this solution useful in continuing online learning during these times of emergency. In another video presentation, I will show the details of extending the wireless local area network of Moodlebox paired with internet in a box, and this time using a dedicated router for the DHCP server. That solution would be easier than the one presented in this video, but slightly require more resources.